Now, as we go on to topic 5 of chapter 2, we're going to continue our work with factoring trinomials, but in this case, a will not be 1. So this makes it just a tad more complicated. And even though we used these techniques in the previous lesson a little, we'll have to use them more. Guess and check, trial and error. So the same protocol will be used that we used before. Let's raise it up and get started. Is it in standard form? Yes. Are there any common factors that can be taken out? No. So 2 sets of parentheses. And again, the strategy would be to write out your trinomial and 2 sets of parentheses underneath. Now here our a term is 2. So we could go 2x plus x. So when we multiply our first term, we get this. Now, when we think of 10 being here, we have to think of our factors. 10 and 1 will not give you a 9. 5 and 2 will not give you a 9, but if you did it this way, watch. 5 here and 2 there. Now my inners are 5, my outers are 4, it's going to add up to 9, and they'll all be plus. And again, we FOIL this to check, and it does check out. Now in example B, again, are there any common factors? No. So we're going to have 2 sets of parentheses. Now here is the case where a was prime here and there was only the 1 set. Here we can have possibly 2 sets. We can have a 3x and a 2x, or we could have a 6x and an x. So there are 2 possibilities with it being a 6. So again, it's guess and check. And then sometimes you can see it ahead of time. So if we went here to a 10, which would be a possible 5 and 2, when I see this, I get a 15. This is a 4. We get an 11. So this is the set here. We're not going to use this one. If this one didn't work, then we'd try this. Guess and check. So what will be our signs here? Well, we need a negative middle term, so 3x times a negative 5 give me a negative 15, and this is a positive 4, and now it FOILs, and this one checks. Now notice here there is a common factor of x squared that we have to take out. Now we get 4x squared plus 23x plus 15. So we have an x squared and 2 sets of parentheses. Now we could get a 4 and a 1, or a 2 and a 2. And I don't know which one it is. So let's try a 2x and a 2x. Okay, we're guessing and checking. Now 15 could be a 5 and a 3. I don't think it's going to be a 15 and a 1. So this is going to be 10 and this is 16. So this doesn't work. So we take our eraser and let's try here a 4x and a 1x. Yeah, I see this is going to work now. Because my outers are 20, my inners are 3, and that gives me that. All right, so just to show you how we guess and check, and then we FOIL to see if we got it right. So on your exit exam, you know, this is the kind of work that we would need to see. All right, let's raise it up. Now in letter D, is this in standard form? No. So 5a squared minus 34a. My daughter calling me, all right, or us. My wife picked it up. Okay, so we now have it in standard form. So, no common factors. 2 sets of parentheses. This is prime, so that helps out. It has to be this. Now, when I see a 34 as a middle term, 5 times 7 is 35, minus 1 is going to be 34. So this would have to be negative, this would be positive. We FOIL it, and it checks out. Now in letter E, is this in standard form? Yes. Is there a common factor? Well, we could take a 2 out of here, not out of there. How about a 3? If we add these together, this is 9. Add these together, this is a 6. Add this together, this is a 9. So when we add the sum of our digits and get something like this, this is the rule of 3s. We know we could take a 3 out of each term. So let's try that. We can take a 3 out of there. And 3 times 12. And 3 goes into there, and we get a negative 17 and a 6. All right, there's no other common factors. So now 2 parentheses, and here we have a dilemma. Could be a 12 and a 1, a 6 and a 2, a 4 and a 3, and then of course you could reverse these, and you're just going to guess and check. Well, I'm going to try the 4x and the 3x. Now if this didn't work, I would try something else. Now here I'm going to put a 6 and a 1. That would be 24, 21. So that's not going to work. Now they have to be the same sign, both negative. So I end up with a 6 here. How about a 3? A 3 and a 2. This would be 8. No, that's not going to work. And after fiddling, again, I have to think about these just like you would. I'm going to go for a 3 and a 2 there. And they both have to be negative. So my outers, a negative 8. My inners, a negative 9. That adds up to a negative 17. And my last, negative times negative gives me a positive 6. So this is a good one. All right, let's take a look at this one here. Is there a common factor? And the answer is yes. I could take a 2 out of every term and y squared out of every term. So this is an intermediate step. This will be 7x squared plus 4x minus 3. So now 2y squared, 2 parentheses. And I like it when my a term is prime like this, so I know I only have the one choice. And I have a 3 and a 1, so that's not going to go. But if I put the 3 here and the 1 here, my outers are 7, my inners are 3. So I need a difference of 4. So if this is plus and this is minus, and I FOIL this, I get that. So this is the answer. Now, none of these up here were equations, but we could have made them into equations just by adding a 0. And then they would be solved by using the property of the factors of 0. All right, so here we are asked to solve this equation. So again, we look for common factors. There is a y to the third here. And this now becomes 9y squared plus 6y minus 8. So we have y to the third, 2 sets of factors, or parentheses, which will give us factors. Now we want a 9, and factors of 9, I'm going to have to guess and check. But I'm going to go to a 3y, actually. And a 3y. Now one's going to be positive, one's going to be negative. And if I put a 4 there, and a 2 there, yeah, that's good. This is a 12 and this is a 6. Okay, I lucked out. So I would need a positive 4 and a negative 2. So again, y to the third equals 0, or 3y minus 2 equals 0, or 3y plus 4 equals 0. So this is y equals 0 3 times. We only write it once. Here it's going to be or y, transpose that, becomes a positive 2 divided by 3, or this one becomes a negative 4 divided by 3. And there are my, actually we needed 5 answers. 3 are 0, we only write it once, and there's this and this. Let's check them out. And they check out. So let's go on to our last example, or next to last I should say, where we're given this in function form and we're asked to find the zeros. But it starts off as 10x squared minus 13x equals this, so we're going to bring this over as a negative 3 equals 0 to put it in standard form. Now, no common factors. And this is a 13 in the middle. Two phone calls and one tape here. But anyway, again, I started to factor this. I tried a 10 and a 1 and it didn't work. So I went to 5 and 2. And then I saw that 3 times 5 is 15. Minus 2 is 13. So this is it here. So this would be a negative 15, a positive 2, and we get 5x plus 1 equals 0, or 2x minus 3 equals 0. Now again, as we prepare for the exit exam, the work that you show is going to be super critical, because without the work, you don't get credit for your answers. So this transposes to a negative 1, and then divide by 5. So negative 1/5. This transposes to a positive 3, divide by 2, a positive 3/2. Now remember, you might get this is the answers, and then they want you to write the equation. Well, you just be reversing the steps to get to your original equation. And remember, this would be written in function notation. G of x equals this, where g is the 0 here. Finding the zeros. Okay, we're asked to find the domain now of this. Remember, domain were the x values. And we want to find out which possible values are included in this domain. Well, for something like this, we equate, again, our denominator to 0. Because we want to find what values of x make the denominator a 0. Those would be values that are excluded from the domain. So 2x, x, and we want a five here and a 4 there, I believe. Yeah, because this is 8 and this is 5 and the difference is 3. So this would be a negative 8 and a positive 5. So a shortcut here would be that, well, we won't do the shortcut. 2x plus 5 equals 0, or x minus 4 equals 0. So here x would equal a negative 5 halves, and here x equals 4. So our domain is such that x is any real number, but x cannot be a negative 5 halves, or a x cannot be 4. These are the values you would have to exclude in defining your domain. Why? Because if you put these values into this expression in the denominator, it would make the denominator a 0. So this is where sometimes this technique of finding the zeros has another use in defining the domain, excluding those values that make your denominator a 0. Okay, 2 more topics and we'll be finished with Chapter 2, Module 2.